1.2 Units and metric prefixes. This table shows the electrical quantity, the symbol, and the SI unit, where SI stands for the International System of Units, with the unit symbol used in this class. Actually, using this book, including DC, this class, and AC, the upcoming class. And let's take a look at them. The first one in the table is the capacitance. Is the quantity for an electronic device called capacitor. Capacitor is an electronic device that used to store charges. We can think of it like a reservoir or container for holding water or water molecules. But a capacitor is used to store electric water, current, or charges. The symbol is the first letter of the word C, and make sure it's uppercase. The unit is farad. Also, the symbol used uppercase F. And then we have charge, conductance, and so on. Not all units going to be used in this class, the DC class. So hopefully you won't be overwhelmed. We only need to know few quantities in DC, and then we are going to learn the remaining ones in AC class. The one that we need to know now, they are charge, conductance, current, energy or work, power, resistance, and voltage. Now let's talk about the metric prefixes. This table shows the prefixes that are commonly used, but not all of them going to be used in our class. In this table, the prefixes start with small, that's the first row, femto, and then increases in downward direction to the tera. Femto, the symbol is lowercase f, and that is 10 to the minus 15. It means 1 quadrillionth. The next one is pico, pico rivera, pico. And then the symbol is lowercase p, that is 10 to the negative 12, is 1 trillionth. And then we have nano like nanotech. The technology is based on working with small molecules. Nano is 10 to the minus 9, that's 1 billionth. We have micro, like Micromedia, Microsoft, also dealing with very small things. Microcontroller. So micro, the symbol is a Greek letter called mu. It looks like a U, but with a longer nose, binocular nose. And that is 10 to the minus 6, is 1 millionth. And then we have milli, like milliliter, milligram, that lowercase m represent a milli. Equivalent to 10 to the minus 3 is 1,000th. And then we have kilo, like kilometers, kilometers, kilograms, using the lowercase k to represent it. It means 10 to the third. That's 1,000. And then the next one we have mega. Mega means million. If you play lottery, you know it, like mega million. That means 10 to the 6, which is 1 million. And then we have giga, like a gigabyte. However, gigabyte is related to computer. That giga has a little bit different definition than the scientific giga. For this giga, using uppercase G to represent it, that means 10 to the 9, which is 1 billion. And then a larger prefix is tera. That's T, which is 10 to the 12. That means 1 trillion. In this class, we don't need to know all of them. We only need to know the highlighted ones. We don't need to remember all of this in a week or even a month. If you can put them in the cheat sheet and know how to use them, and by the end of the semester, we remember them, mission completed. Let's work on example 12. Express each quantity using a metric prefix. And this example shows the reason we need to know engineering notation and the prefixes, because we are going to combine the two skills and make them more meaningful. For example, the first question is 50,000 volts. First, we need to convert 50,000 to its engineering notation. We move the decimal point to the left 3 units, so the number portion is 50. And then since we move the decimal point to the left 3 units, the power of 10 has a exponent 3. So the answer is 50 times 10 to the third volts. This is in its engineering notation. However, the power of 10 part can be replaced by corresponding prefix. 10 to the third, that's a kilo, K. So these 50,000 volts can be written as 50 kilovolts. Now let's move to question B, the 25 million ohms. So first, we're going to convert that 25 millions to its equivalent engineering notation. We move the decimal point to the left 6 times. So the engineering notation is 25 times 10 to the 6th, and then the unit ohms. And then now we're going to work on the 10 to the 6th. That is a million. So we replace the 10 to the 6th by the letter M, the mega million. So this answer should be 25.00. I keep 2 decimal digits, and mega ohms. The last question is 0.000036 amps. First, we convert the number portion to engineering notation. We move the decimal point to the right 6 times. So the number is 36 times 10 to the minus 6 volts. And then we replace the 10 to the minus 6 by the corresponding prefix. That is a micro. A micro is 10 to the minus 6. So after replacement, we get 36.00. I keep 2 decimal digits and a microampere.